cancel out. And then I'll have a negative here, which also gets squared. So you'll end up with this. And, well, that's 2.25. H squared plus 1.5 H squared. 7 times 1.5. 1 and 5. Sorry, 10.5 H.
You said 7 times 1.5? Yeah.
Okay. And then 3.5 squared. Well, 0.25. We have a nice little quadratic equation here.
Why can't you just add the 2.25 H squared and the 1.52 H squared?
There's absolutely no reason why we shouldn't. That's the next step.
Okay.
All right. So it's a quadratic. We need to get like terms together and everything on one side. So I have 3.75 H squared plus 10.5 H minus 41.25 equals 0. I assume someone's going to correct my mistakes I made them.
It's perfect. You didn't make any mistakes.
Now what?
Quadratic.
So H, which is the final velocity of the 3 kilogram mass, negative 10.5 plus or minus the square root of 10.5 squared minus 4 times 3.75 times negative 41.25 divided by 2 times 3.75. There are 2 answers. I want them both. One of which will be correct, one of which will tell us something else.
X is equal to negative 5 and 2.2.
Units?
Meters per second.
So,
Any objections?
all right, I know that C is equal to negative 3.5 minus 1.5 H. So we can find out the value of C, so that was H right there. C, therefore, we stuck negative 5 in, we'd end up with 4. And if we stuck 2.2 in, negative 5.8.
I got negative 6.8.
6.6, yes. Silly mistake on my part. Meters per second. So the question is, I got 2 answers here. I got the negative 5 and 4, or the 2.2 and negative 6.8. Which is the correct answer?
What are we looking for again?
The velocities of those 2 objects after they collide.
And they're not sticking together.
And not sticking together in a
So-
perfectly elastic collision.
So would the 4 meters per second be well, in this instance, because we had the block on the left and the block on the right, the 2 kilogram one moving now back to the left would be this -6.8, and the other 3 kilogram block would be the 4 meters per second going this way?
These two go together, or these two go together. It's not these two, it's those.
So
It sounded like you were there.
Yeah, so the -5 would be the 2 kilogram box going to the left, and the 4 would be going.
H was for the 3, so this is the 3 kilogram here. So this is the 3 kilogram, and this is the 2 kilogram.
So it'd be the bottom one.
The bottom one. So what's wrong with the top one?
The 3 kilogram box is now moving to the right, and we said that right was positive.
That is true. Okay. So you're assuming that they're going to bounce and go in opposite directions.
Yeah.
Okay. Doesn't always work that way, but in this case, yes. What is this first solution? Mathematically, it gives us the exact same as the initial momentum, gives us the exact same as the kinetic energy, initial kinetic energy. What is the first solution?
4.
That math Tourette's kicking in again?
No. I genuinely thought that's what you were at. The first solution.
Physically, what is this first solution? What is the physical meaning of it?
How fast they're going after they collide? Or how far they bounce off of each other? Okay.
Newton's laws. Now I have physics Tourette's.
If you're going to have Tourette's, physics and math are probably the best ones to have. I assume somebody does it, but I don't know. It's not just profanity. Have we seen that -5 and the 4 before? Jack got really close to he almost said it twice.
Say what you said again, Jack.
My first thought was because they bounce off of each other, they would be going in opposite directions, so we would use the first one because the 3 kilogram box would just basically turn around because it bounced off the other one.
Yeah, in the first solution, the 3 kilogram, in this solution right here, the 3 kilograms still moving to the left, 2 kilograms still moving to the right. Before the collision, how fast was what was the velocity of the 2 kilogram mass?
8 meters per second.
What was the velocity?
1.4, -1.
Negative. 2 kilogram mass was going this way.
Or the 1.4. Because we set the final, no, that's what we said.
All right. Sorry, Joey?
4 meters per second.
Yeah. What was the initial velocity of the 3 kilogram mass?
5.
All goes
Not 5.
negative.
Yes.
Those.
We have asked the math to find out, give me a situation which has the exact same kinetic energy and the exact same momentum as we started with. Well, the fact that they never collided gives us that. This is the original, they haven't collided yet, or they passed through each other. This first solution is the original problem. The second solution is they actually collided. This method here, this is one of 3 methods. This method here has the nice advantage of one of the answers better be the original situation. You got an immediate check. We've done something right because one of our solutions is the original problem. The disadvantage is you're doing a quadratic.
It's not that bad. You just plug it into it.
So
The other 2 solutions do not use a quadratic.
But do they provide more? Like, is this like a surefire way to get your answer?
Oh yeah, this works.
So like is
I'm going to go over 3 methods, pick one of them, and know how to do it. Because I will tell you, on the next test, with the calculator test, there will be a problem with a perfectly inelastic collision, and there will be a problem with a perfectly elastic collision. I am telling you now. I'll probably mention it later on also. But I've said those things before in the past, and always surprised at the number of students who have no idea how to do those problems. But there will be a perfectly inelastic and a perfectly elastic collision problems on the test.
And that is a lot because considering our tests are only like 7 questions, I'm like, yeah, something like that, right?
There's definitely more than 7.
Yeah.
We had like 10 on the last one, at least.
What?
At least.
We had.
At least 8. I
This
know.
would be part A and a part B. This is one question.
We have a bunch of parts, so.
Anyway,
Like question 1, and however many parts it has, but it's still one question. I think it.
yeah, we'll treat this as one question.
Right.
Or unless I have a storyline, then it might be 2, but.
Right.
The root
It'll be
will work
2 of, like, so one of these is gonna be PIC, the other one's gonna be PAEC.
Yes.
So, 2 of, okay, max 10. That's still a good chunk of the test to prepare for. Much appreciated.
No problem. All right. Questions about method number 1?
So the first set is how it started, and then the bottom set with the 2.2 and the 6.8. Does that mean anything?
Like this?
Yes.
I mean, that's the actual answer, that the 3 kilogram mass, as you said, will indeed be going to the right because that's positive 2.2 meters per second, and the 2 kilogram mass will be going to the left at 6.8 meters per second. They will hit and bounce off each other.
And now, because you said earlier that it's not necessarily that they'll just bounce off and go to the other directions, like if one's like a lot heavier than the other one.
Yeah, I mean,
would it show
big
like
truck and ball.
Yeah, would it show that like a 1,000 kilogram truck would be like basically 0, and then the other one would be like 200 meters per second? Would it still show?
It would come out with probably a very small change in the massive object and a huge change in the little object.
Okay. But it would still work.
Yeah, oh yeah. But again, one-dimensional collision and closed system. So just those 2 objects, nothing else involved. Do not bring gravitational pull into it.
So is the textbook that we have online, is that the same textbook that's going to be used for 152? Nice.
Unless they come out with a new edition, but I'm still working on the old edition.
Okay.
So it was close.
All right, and now what you're thinking is, what's the other method? Do we have time? Let's find out.
Speed run.
Speed running.
So if it's speed learning, if you don't learn it in 2 minutes, tough, you just go on to the next one.
Yeah.
So,
And you never come back to it.
unless somehow you click with it. All right. So I'm gonna let, these are the velocities initially, and then I'm gonna use C and D for velocities, so I don't have D defined as anything. All right, so I have M, A plus M, D, B. That's the total momentum beforehand, is equal to M, A, C plus M, B. I'm gonna change that to 1 and 2, that just makes more sense to me right now. All right, mass times velocity, initial is equal to the final. My kinetic energy, 1/2 m1 a squared plus 1/2 m2 b squared is equal to 1/2 m1 c squared plus 1/2 m2 d squared. It's a perfectly one-dimensional, perfectly elastic collision. 2 equations. Assume I know what A and B are, and I'm trying to find C and D. I got 2 equations, 2 unknowns. So first off, can I get rid of anything on this equation?
No.
Or
indeed.
what can we get rid of here?
The 1/2?
Yes, we can get rid of the 1/2. It's a common factor.
Is that D still your kilograms?
No. This D is a final velocity of mass 2.
Okay.
I didn't define capital D any other way on board at the moment. So what I'm going to do is I'm going to get all the M1 stuff on one side and the M2 stuff on the other. So for this equation, let's take this equation. For this equation, I get m1 a squared minus c squared. Basic, that's 2 steps. Let's put in the intermediate step. m1 a squared minus m1 c squared is equal to m2 d squared minus m2 b squared. So just brought this over to the left and that over to the right. Factoring the m1 out, I get m1 a squared minus c squared is equal to m2 d squared minus b squared.
Okay, never mind. I was thinking like you could just put the square on the outside.
Yes, absolutely not. All right, but this can be factored. I got the difference of perfect squares. How does it factor?
Oh, we said so a plus b, and then it's a squared 2ab and b.
Let's pull it. That insurance is really tough.
Hold on.
We didn't do it earlier today.
Oh, well.
Difference of perfect squares. Where's the math power when you need it? That's that right there. You might be able to connect it, but I haven't seen that before.
Oh, yeah.
Hopefully brings back some fond memories. If it brings back no memories at all, I'm not quite sure why. All right, anyway. So this is m1 a minus c a plus c is equal to m2 d minus b d plus b. So this is still just from the conservation of kinetic energy, the perfectly elastic piece of it. That's all that is. We now take the momentum equation, and I'm going to do the same thing, bring that over to the left and this over to the right. So I get m1 a minus m1c is equal to m2d minus m2b. Factor the masses out. That m1 a minus c is equal to m2 d minus b. So that's just from momentum, conservation of momentum. And now, I'm going to divide the left-hand side by m1 a minus c. And I'm going to divide the right-hand side by something equal to that, m2 d minus b. M1's cancel out, a minus c cancels out. M2 cancels out, d minus b cancels out. What I'm left with, a plus c is equal to d plus b. And putting in terms of velocity, let's actually get initials together and the finals together. So we have a minus b is equal to d minus c, or v1 initial minus v2 initial is equal to v2 final minus v1 final. So the difference in the velocities beforehand is equal to the difference in the flip of the velocities afterwards. And slightly, in what I'm going to call in English, this is the relative speed of approach, the relative speed of recession. In the problem that we just did, we had -7 is equal to 2c plus 3d. That was the momentum equation. We don't have to use the kinetic energy equation. We can use this down there. So we had, let's see, wait, one that was going 4 minus -5 equals, oh, that was, should be an H, not a D there. equals H minus C. From this, I see that H is equal to 9 plus C. Plug that into here. Negative 7 is equal to 2C plus 3 times 9 plus C equals 2C plus 27 plus 3C. Bless you.
Thank you.
I get 5C, and then subtract 27, I get negative 34. C is negative 6.8 meters per second, which is what we had before. Plug into here, and we get H is equal to 2.2 meters per second, which is what we had before. Down there.
And that's speed physics.
So when we would do this method, whatever it's called, we would just do the V1I minus V2I equals V2N minus the
V, yes,
We don't have to derive it again.
no. Although I have had some students do that.
It's a lot of work.
Yes.
And do these methods have a name?
Pardon?
Do
I
these-
call it method 2.
Method 2.
Yeah. All right, we're out of time. We're way past out of time, so I guess the answer to my question of do we have enough time? No. But I'm going to leave you with a question here of what happened to this solution? It disappeared. So the question is, at what point did it disappear? If you know it immediately, great. If you don't know it immediately, I guess Tuesday we will find out.
Green apple.
Is that a country song for us now, or?
That's everything.
Yeah, growing up, Tourette's, I mean, the definitions have changed over time, or at least popular definitions. Tourette's was just sudden bursts of profanity. And then I found out it's actually any impulsive behavior,
Sound or anything.
sound, action, whatever it happens to be.
So Ashley could have Tourette's and just like, oh, how you doing, Jack? Just talking to the side.